Hey everyone, welcome. Azure Cosmos DB Live TV. I'm Mark Brown. Welcome everyone. Today I've got with me a couple of special guests, Ravi Tella and Naveen Singh. Both you guys are on our engineering team. Like I usually have product managers on this show. But I do bring engineers on from time to time. I've had Machin on, who you guys both work for. And I've had Matthias on, and I've had Cassandra on. Who else? I know there's probably others, but anyway, I like having engineers on because, frankly, you guys do some of the most interesting work. Like product managers talk about stuff, but you guys actually go and build stuff. And been wanting to have you guys on for quite some time. You guys have been working on something that's quite cool, and wanted to have you come on and share it with our customers. So Ravi and Naveen, you guys have been working on building kind of a larger benchmarking framework around Cosmos, or at least Azure Databases, I guess. And wanted to have you talk about that. I guess YCSB is amongst one of those, which is a widely known benchmarking framework for databases. And anyway, Ravi and Naveen, why don't you kind of just tell us what you've been doing and show us, because it's just remarkable, and this is why I wanted to bring you guys on. Is the kind of the stuff you guys have been able to do is just pretty amazing.
Great. Thanks for the nice introduction. Yeah, by the way, one correction. We work in the Sujit's org.
Oh, you're in. You are.
Not a big difference. Yeah.
Oh,
fundamentals.
All right.
Yeah.
Sorry, Sujit.
Yeah. I think you have to invite him next time around.
Sure.
Yeah. So, but quick introduction. So, I'm Ravi Tella, a part of the Cosmos DB engineering team. So we on the team primarily focus on Cosmos DB fundamentals like performance, availability, reliability, and resilience. So a lot of things we do actually are very cross-cutting, and they span many Cosmos DB subsystems. And we also build open source OSS frameworks and tools, and then we make them available to customers so they can actually validate these fundamentals end to end and see how Cosmos DB could solve their problems. Naveen is here alongside me, not physically, but virtually. So we closely work together in a lot of things. Naveen, would you like to introduce yourself?
Yeah, thanks, Ravi, for covering what we do. And myself, Naveen Singh, and I work along with Ravi. And we basically, as Ravi mentioned, works on the fundamentals and cross-cutting concerns across the Cosmos DB team. We make sure that the availability, the performance, and all those aspects which affect the customer directly work perfectly in the production.
So in a way, you guys kind of do. It's almost like a customer engineering type of thing. Is that a good way of putting it? With these recipes and these things you guys are building?
That is absolutely correct.
Yeah. Okay.
Yeah.
Into the
and these are for customers that are basically like pushing the envelope on the service, right? Like at the very bleeding edge of what you can achieve. Is that also kind of characterize kind of the work you guys are doing?
Yeah. I think we want to make sure that all of our capabilities, that hygiene is maintained end to end. They're always working as expected, right? And then if we see any gaps, then we go and design solutions and have them fixed.
Got it. Okay. Well, that makes sense. How kind of the work you guys have been doing kind of ties in to the topic that we were going to talk about today, which is this benchmarking framework. So yeah, can you tell us more about this?
Sure. Mark, I actually have a question for you. Do you know how many databases we have in Azure? Guess.
12.
You know why I asked you? Because I don't know. I thought it will definitely be more than 10, but I did not know if it's 12.
Yeah, I mean, that's a great question. For all first party or first and third party?
First, I would say first party. Or more easily accessible, maybe as well in Azure. Right. Some of them are
the
not.
SQL VMs and SQL MI, is that one database or two?
I think we can say one. I think similar performance characteristics.
SQL MI and SQL VM and SQL DB, is that one or two?
I think maybe close to one, but I would say Mongo API, Cassandra API, they are different.
They are different, yeah, even though they run on the same underlying kind of core storage and compute infrastructure, or at least somewhat. You'd say those are 5, right?
Yeah.
So you got 5, 6, 7.
But definitely 10, right?
8. That's just within our portfolio, and adding Flex, we're at 8. You put SQL DB in there, 9. ADX 10. I'm going to say SQL MI is another. That's a 12. SQL VM 13. Azure Stream Analytics. Are we going to call that a database? I think we should. 13,
yeah, 14. Because it is stateful in a way, right?
Yeah. The old Cosmos scope, the ASL 15. MySQL 16. Maria 17.
Yeah.
I know we're not done yet.
Yeah, but I think that's enough for now. I think the point I'm trying to make is that there are so many options in Azure itself, right? Yeah. So I think it's very hard for customers to make an informed decision on which database suits their workloads in a reasonable amount of time. I mean, you don't have weeks to spend on just picking the database, right? I know it's important, but you want to get to there as fast as possible, right? So today, I think oftentimes it takes a lot of time, a lot of choices we have, which is good, but sometimes it can also have its own downsides in terms of getting and picking the right one. So as you know, right, when we talk to customers, one of the key things they look for in a database is for mission critical workloads is the performance of the database. So with this framework, what we do is measuring the performance of Azure databases. The aim is to make it so simple, like one click, and you can run a workload and understand the performance characteristics of that database for your workload. Because with that, now you're simplifying a lot of things which you otherwise could have taken 2 weeks or 3 weeks, right? Yes, there are many open source tools which can do that. But then there are many other things you have to do around it to make everything work together to get to where you want to, which is picking the right database, right?
You bring up a key point. I just wanted to stop for a second. It's easy to compare databases based upon kind of the features they advertise or say that they are for.
Right.
Much more difficult to actually put things to a test, right? And certainly quite expensive because there's a lot of time necessary to set all this up, get everything prepared, get all the testing and everything in place. So is what you're suggesting, like the work you guys are doing here really just kind of helps drop that friction to near zero to allow people to do this aspect of kind of that kind of work. Is that
exactly? They can do it quickly and they can do it correctly.
Right.
Sometimes
even more important.
Yeah. So to begin with, since we are from Cosmos DB team, so we first focused on the SQL API, and then of course this is a framework, but the framework itself should ultimately, we decided, should rely on an open source industry standard to actually perform the benchmarking. Yep. So we started off with for SQL API or the core API. And then the tool we chose for this NoSQL database is YCSB. So I think a lot of customers we work with, they're using YCSB. They like it and they don't like it as well. They like it because it's an industry standard and there's documentation around it, how to use it. But the reason they don't like it is it's great if you want to run it in a single VM or a single client. But then if you want to benchmark with multiple clients, aggregate the results, so on and so forth, so it becomes a big hassle. So we actually, with this framework, what we do is we simplify that process of using any open source benchmarking tool. But to begin with, we started with YCSB. Got
it. Yeah. So this could be applied to other benchmarking tools. This whole thing, this framework, right? Because it is a framework.
Yeah. This is completely extensible. So right now with YCSB, as I said, we GA'd the SQL API benchmarking, and just this week we also GA'd Mongo API as well. So customers can use this framework to benchmark SQL API and Mongo API with YCSB. But going forward, we'll also add our .NET SDK as well. So currently with YCSB, it's using our Java client, But there are a lot of customers, as you know, both internally and externally, who use our .NET SDK as well. So we'll be bringing that on board too. So customers can then use the same framework to benchmark, SQL API with our .NET SDK.
Oh, that's kind of cool. Because you're right. YCSB is built for Java, basically. So you would need to have a Java client or Java driver in there to do it. That's very cool that you're doing this for .NET as well. Are there other database benchmarks that you're looking at rolling into this? Because there's a lot of them out there, not just YCSB. I mean, of course, for our world, the YCSB would be kind of one of the ones you would use. But are there others that you're thinking about in the future?
Yeah, we do. I think there are some other partner teams who are interested in leveraging this platform and this vehicle to actually have some, MySQL Postgres benchmarked as well using the same tool. So we are actually working with them, and I think you will hear more maybe later this year on that.
Great. Yeah.
So just on that, for the Postgres, there is a Hammer DB, which is itself a tool, and one of our partner team interested, and they started looking into that area, that how that can be onboarded on this platform.
Okay. Yeah.
So that's why I think when we came up with the name, I think Naveen didn't want anything related to Cosmos DB in it. So that's when we decided let's do a benchmarking framework for Azure Databases.
No, that makes sense, right? Because you're casting a wide net here, right, for folks, and they can all come and play. So, yeah.
And this framework name can be intimidating, but at the bottom is just simple: one button click, provision the machine, provision the database, and see the result in a very easy fashion. That's the fundamental. So whichever tool we will go forward and add and pile up on the top of it, that will be the fundamental. It should be extendable to the infinite throughput, and the result should be very easy to look and make a graph, and customers can use it for different purposes.
Yeah, that's great. Right, one click provisioning, easy config.
Yeah, so
another big red easy button to start it.
Yeah, I think a little bit more on that, like Mark. So today, like most of the, like I already touched upon that, like most of the benchmarking tools, open source tools, they are designed generally to run in one machine, right? One client to generate the load. And then when you want to actually do some, benchmark at a scale, then that immediately becomes a problem because, for example, in a YCSB case, and this is true to most benchmarking tools out there, that you will have to manually coordinate starting multiple clients, distributing the work between them, right? And then making sure they all start more or less at the same time, and then manually aggregate the results. So that is not too convenient, right? If you want to really do it at scale. So this one-click thing actually brings all of that together. And more than that, because when you want to benchmark something, it's also about identifying the best practices, right? For example, as you know, for Cosmos DB, we have published many best practices for our Java clients, right, or .NET clients. And we also have some best practices around like what type accelerated networking for best performance using direct mode, so on and so forth. So also the amount of CPU and memory utilization on the client or availability of CPU. So all of that are built into it and optimized. So when you run this recipe, you're running with the best configuration we have, these workloads, and with the latest bits of our SDK to get the best results for you.
Got it. I just kind of a technical question. How do you coordinate the starting of the benchmark across the group of machines that are provisioned within this?
Yeah, we have a great design. Actually, this design is a brainchild of Naveen. So I will let him answer it. So we do use Azure storage to actually do it in a decentralized way and use that as a state store for coordination. Naveen, you want to chime in?
Yeah, so the fundamentals are very simple. So we we run the workload on the multiple machine. Let's say the customer choose 10 machines. So 10 machine are putting the load at the same time, but we want to have a coordination between them, like the aggregation of the metrics. And if first client is adding the data from this range to this range, the second will do from this range to this range. These all coordination. We leverage the Azure storage, blob storage, and we in the starting of the run, we create a metadata. So all those 10 machines talk to that and exchange the information between each other. And that's how they orchestrated. And at the last one, once all the workload finished, they again see, okay, everything finished. The master node will do the aggregation of the result.
So they're basically reading from blob storage, and you're using blob storage as a way to trigger.
Yeah, table storage, like as you can see on the screen here.
Storage, yeah.
So we capture the job metadata, and also this is used to so all the especially when you have more than one client running, right? So they all coordinate based off this.
So is there some kind of polling mechanism that's looking at this and saying, "Oh, okay, I see something here that says get started"?
Exactly. Exactly. So
okay.
There is all the machines start with this framework. All the machines supposed to start at the same time, but because of we are using the ARM template, there might be a little bit delay. So we go and keep on polling. Okay, do we have the information? Do we have the information? Once all the machine have the information, let's trigger the workload.
Oh, got it. Okay. Oh, does the job start with the ARM template itself?
Yeah.
Okay. So got an ARM template. I'm going to go provision a VNet, subnet, and I don't know, 5-10 VMs in there that I'm going to run, and a storage count with table storage and some blob storage for results. And then you're saying once that ARM template, once the deployment is complete and everything is marked as succeeded for deployment, you're saying that's what actually starts the job?
Yeah.
Oh, okay. Yeah, I just thought you had some, I don't know, button or something, and then you just pushed it, changed the state, and then it picked it up. But you're saying it's the ARM template that actually starts the.
Yeah, I think let's why not just maybe this is a good segue to actually do a quick demo. I think that'll answer many of the questions.
Yeah, sure. Let's do it.
Okay, so this is a repository, right? You guys are already seeing it here. Yep. So I think if you're a new customer, you can go to Getting Started. And here, I think what we call them as recipes. So there are, read, update, and write recipes. So it's write workload, update workload, read workload. So each recipe comes with an ARM template. Okay, so this, for example, if you go to 10,000 RPS here, right? So this describes what is a recipe definition or a workload definition, right? This is for a SQL API. The benchmarking tool is YCSB. It's a read workload, and the RPS is 10,000, right? And the duration is 1 hour. And the number of documents in the database in the load phase will be 1,000. So the 10,000 RPS is workload is run against 1,000 documents in the database. And each document is roughly around 1 KB, which is a YCSB default. And then we also give the instructions on, the only thing you need to give is a Cosmos DB, create a Cosmos DB account and give it the credentials, and then a storage account and the connection to the storage account, and then a resource group. And then we are good to go.
Got it. 10,000 RPS, I'm guessing that's just one machine, right?
Yeah, 10,000 just one machine. But we'll later look at some other recipes which need much more.
Yeah, I'm really excited. I won't steal your thunder, but you got an RPS that's actually quite awesome. I'll let you share that when you get there.
Yeah. So first thing, what we need, like if you look at this, right, the first thing, we need to create a Cosmos DB SQL API container, right? 12,000 RUs per second. Here we are choosing manual, but because the workload is consistent in terms of RPS, so there's no point choosing any other option. So manual is the way we took. Let's go ahead and so I already have a database pre-created here. The ID is the partition key, and also it has a manual throughput of 12,000 RUs per second. Everything looks good. No magic here, right?
Yep.
Straightforward. So now I've also created a storage account. So I have it here, and the storage account key can be retrieved from here, right? The two things are there. So let's go ahead and click on Deploy to Azure button. So when I click on this, is an ARM template which actually takes all the input, and then it actually calls another ARM template which actually initiates the resource creation.
Yeah, so this will call, like, I think everybody familiar with deploy to Azure will call the custom template deployment blade in Azure portal there, and then basically let you fill in all your user defined values within there for whatever you want, region, names, all that stuff.
Yeah. So we have the subscription here. So let me go ahead and add my pre-existing resource group. I think one thing to remember is we called out in the documentation as well. Just so this resource group is where your client is getting deployed, right? So just be sure that the resource group, the client location, East US, and your database location are the same. So that's another best practice, right? So make sure that you have them in the same region and not in a different region. Unless there is a
things
reason
across a WAN are already hard enough. Don't run a benchmark across a WAN. It's a bad idea. So at least across hundreds of miles.
Yeah. So the next thing I'll do is after that, there are only three other things. As you can see, we need to give the connection string for the storage account, because that's where the results grow, and the job status also is coordinated through there, and the Cosmos URI and Key. So let's go ahead and add that.
By the way, I might have a shortcut for you that would keep you from having to manually plug in a storage connection string.
Yeah,
that'd
be good.
Yeah.
What is it? Maybe I think I know what you're talking about. For simplicity, I'm using this here.
You can get the resource ID for a thing and then call like .key or .primary key. It depends what the RP defines for the thing. Like for us, it's primary master, secondary master, primary read only, secondary read only. But for other services, it's key 1 and key 2. It depends
then that I don't know.
But you can actually output that from a previous deployment, make that a dependent or a parent of the other, and then just inject it straight in there. So it's basically like a it's like a zero-touch deployment.
Cool.
Yep.
Yeah, that'd be great. Yeah, and then this is the password for the virtual machine, which will actually where the client gets deployed and workload starts. Okay, and then if you see, there's just three things: resource group, make sure the location is the same, the connection string, Cosmos URI, and key. And then we already picked the right size of the VM. And by default, this is the virtual network which will be created, but you're always free to plug in your own virtual network. So if you want to use any special networking capabilities like private endpoint, then if you have a virtual network configured with private endpoint for Cosmos DB, then you can just bring it here and everything will work. And then this is the number of threads, again, tried and tested, optimal for this workload. 1,000 is the number of records in the database. So another interesting thing is when you use these open source tools, including YCSB, you first have to run a load phase, and then you have to run your actual workload, right, for a read or update workload. So with this capability we combine both of them into one click. So when you click once, the loading happens, and then after loading is complete, the actual workload what you want to run, in this case 10,000 RPS read workload, that happens.
So you're triggering a data load after you run this?
We don't have to. It is combined into one step.
Oh, how did you trigger the actual loading of data? This is something I see people asking all the time. Like they have to run like a manual PowerShell or a CLI script or something to do some data load or whatever. So you're triggering it after a deployment.
Yeah, after the deployment. So when you deploy this, it creates the resources and the call returns, but it hands over the execution to a script within the client, which then calls YCSB to actually first run the load phase. And then once the load phase is done, then it initiates the actual transaction phase if you want to use the YCSB.
So do you inject the script into the VM? Is this some VM extension that you're running then?
Yeah, so we use, for this, we use VM extensions. And the VM extension basically calls downloads the framework itself. So what you see here, right? It downloads the framework itself, and the framework will have all the master script and other dependencies within it. So it will then go and download the YCSB code as well from the respective GitHub repository. Everything happens on the VM. It downloads, it builds the jar file, and then executes.
Oh, very cool. That's
good.
So
you don't need anything, and you can execute the same with Azure CLI as well. So
much easier, right? Like you normally have to RDP or SSH into each of these things and deploy it, and just annoying and time consuming. It's just insane how it's just amazing. You guys really have this down to like a single click, basically.
Yeah, I think internally we also use it for some of the things we do. So I think even forget about the customers, we find this quite valuable. I think Naveen can speak to it more, like some of the things he is doing.
Necessity is the mother of invention, right? So right, you scratch an itch and you make a thing because it makes your life easier, and you just get that's just added bonus that makes customers' lives easier too. So very cool.
Yep. All right, so let's go ahead and click create. I mean, am I missing something here? I don't think so. I think everything.
No, I think you're good.
Yeah. So click create. So when I click create, then that's when the resources are getting created. If a VM with the same name already exists, then it will be used. So you don't have, the VM doesn't get created again. So let's say in my case, I ran a workload this morning, the same 10K workload, because it runs for 1 hour, right? So I wanted some results beforehand. So since I'm running the same workload again, so it's using the existing VM.
Yeah, got it.
It'll be much faster. So it'll just return immediately and the workload starts.
Yeah, so in the reason we made sure that it clear everything from the VM, like all the bits, older bits, and then on the top in the new run, it will just put the new results, files, bits, YCSB, for example, in this case, code, everything. So
got it. So it's just resetting a VM if you redeploy to the same one.
Yeah. And if you see, that's why it returned immediately. Otherwise, if the VM resource was not there, it has to create, it takes a few minutes.
Yeah, it takes a while.
But even then, once it is created, it returns. It doesn't, it's decoupled, or it's asynchronous process. It doesn't wait for the workload to complete.
Got it. Okay.
Now the first thing you want to do is, after that happens, let's go to the storage account. Right. So if you come here, see here, this job has started, not yet finished. It's only one client, and 0 clients have completed. Right? Yeah, I think this is important when you have not important, but it'll be interesting when you run a large workload with 15, 20 VMs, then you will see, some have completed, but some might lag by a minute or two. Okay. So now that will go on for 1 hour. So one other thing is we have a try it recipe or a workload that we only run it for that only executes the workload for 20 minutes or so. If somebody wants to try it, with our free Cosmos DB account and the smallest VM possible, but all the curated recipes run for 1 hour, because that's a true way of measuring performance, right? Even our SLA and everything is for 1 hour.
Yeah.
And one thing on this. Mm-hmm. So for all the recipes, the operation count we configure in a way that it will run with that RPS for 1 hour. But any customer who want to do it for 5-6 minutes just to get a feel, they can just reduce the operation count in the field which Ravi was showing after the deploy to Azure.
Yeah.
And then So
Yeah.
for
So
example, if you remove 1 0 from the operation ground, from 60 minutes, the workload will finish in 6 minutes.
Yeah, great. So basically your test configurations all wrapped up in the ARM deployment.
yeah.
So it's basically one shot and you're done, or you've got it. So yeah, that's very nice.
Yep. Thank you. And so if you go back here, so you'll also, as soon as the job actually starts, you'll also have a container created for the results. So if you see here, the load phase is already completed. So the client has sent the results of the load phase. So in this case, we will see, 1,000, because the data size is 1,000, so it inserted 1,000 documents into the database. Okay.
Yeah.
But yeah, so let's go. So it will still run for another 55 minutes or so. But I have something from this morning. But what you'll see is once it is done, you will see, as you see, we already have the load log here. But we also will have the actual workload log. And we also have a CSV version of it. And more importantly, we'll have this aggregation file. In this case, it's just one VM, but we will have the results. So for that 10K RPS read workload, the P99 latency was 2.5 milliseconds, as you can see.
That's pretty good performance, by the way. Those are all reads, right?
Yeah, those are all reads.
Yeah. That's still good at P99 at 2.5 milliseconds. That's awesome, right? Like our SLA is P99 less than 10 milliseconds, and you guys are order of magnitude faster. Or this benchmark was, which is that's really awesome. I like to see that.
Yeah, thank you. And you'll see more, I think, things as Naveen shows few other things more exciting. If you're not excited enough seeing this.
I'm excited. You know what,
Nice.
Ravi?
I know, I can sense it. I can sense it.
People have to tell me to calm down, not get excited.
Yeah. So that's how it happens, and we also push the out log and error log for the agents which run on the VMs, which actually do a lot of things like triggering the workload, aggregating, and all that. So if there are any errors, you can find them here. So generally, let's go back here. So most common errors, if at all, because the only things you're doing is giving it a few connection strings and all that, right? So the only thing that could go wrong is if you give a invalid storage connection string, or a invalid Cosmos DB a URL or a key. Those are the things which the only things which can go wrong, and when they happen, you can go and check at the logs to figure that out.
Very cool. Can I see some more of the recipes you got up there?
Yeah, sure.
You just showed the read ones that you've got, and you got various ones for those.
Yeah. So one other thing is like generally for all workloads, we run mostly. So this is for the read workloads, right? So these are the P90, P99, and average. This is what we see. It doesn't matter if it is 10,000, 1,000, 100,000. We consistently see these type of latencies for read. And the same thing applies to writes. Obviously, in writes, it's slightly elevated, but still well under our 10 millisecond end-to-end latency guarantees.
Yeah, that's very cool.
Yeah. So what I'll do here is I think this could be a good segue to hand over to Naveen, because he will show you.
Before that, I have a question, and so.
Sure.
So a question, and also want the audience to know the answer. So in this, if you see, we have this read, scan, update, right? Which is a work standalone, like all read, all write, all scan, and all update. But if some customer want to do mix of those, like read and write or read or update, then they can still use the CLI. So Ravi, do you mind showing the Azure deploy file where we have configured the percentage of these things?
Yeah. So let's go to read. Let's do this, and let's go here. It should be.
If you open the base file, then
Okay, I thought we were passing. Okay.
yeah, go in a base file.
Okay.
Infra.
Sorry, yeah, this is Cosmos Infra, yeah. Azure deploy, yeah.
So yeah, the customer, the user can use this and the parameter file, and then use the simple CLI, and they can change anything they want. And here we have this the ratio. Here it is.
Yeah.
They can change the proportion, and it is nothing just coming out of the box from the YCSB. So they can give the percent, like 10% read, 90% update, and all those sort of things. So this is extendable to that as well.
Got it. So you could run a mix of operations,
Yeah.
whether it's reads, writes, scans, updates.
Yeah.
Where does it? So when you put those proportions in, is it picking up the instructions for the operations somewhere else? Where are those?
So once you put the instruction, it will take the instruction, feed it to the via ARM template. It will go to the custom script, the brain where everything is happening, and that accordingly will say, hey, okay, if I have one machine, let's give 10% this, 90%. If I have two machines, do the same thing. So from here, it will go all the way to that custom script, which is doing all the fun stuff.
Got it. Okay. Can you show me the script, what it's actually executing, or?
Yeah.
Yeah. Although it's a little big at this point. We are planning to refactor it as we will onboard more
Yeah.
more databases.
This is the bash script.
Got it. Okay, so it picks up the proportion in here that it's been sent, and each VM gets its own copy of this thing, right? With its its proportion, and then whatever that number is, and then over this script is that when it's going to execute. I see what you got. Yeah.
Yeah, and here if you see the machine index is there at line 71. So every machine know what is their number, and based on that, the thing which we were talking about, the metadata, they coordinate to each other. The master know that it is a master, and others will know that they are the secondary machines.
Got it. Yep. Very cool. It's fun. I like writing bash scripts. I don't know if I would have enjoyed writing that one though.
You don't have to. That's the whole point.
Right. Yeah.
By the way, then now we are talking on the script. Just quick thing. So we have this Python script as well in this framework, which is actually doing the last part, which is combining the result, aggregating it, and showing it at the last, either 10 machine, 15 machine. It will aggregate all your percentile and show it to you. So we have a mixed match of language and the platform we use.
Got it. Okay.
So if you want to do a workload completely custom, so we didn't put the full details of it, but we expose one recipe, build your own, which actually opens up everything. So now you can from here, let's say if you want % read, 50% writes,
Wow, that's great.
Make sense?
This is really a framework. Like you can now just build your own and go literally build your own.
Yeah. Create your own workloads.
Yeah. All right.
And before I hand it over, one other thing I wanted to quickly show is that we also recipes are also every page starts with for recipes a simple one where you can do with 400 use free accounts with the smallest database. It's like I said, so the latency might be slightly higher because it's not running for the whole hour.
Can I configure the VM size?
Pardon me?
Can I configure the VM size that is deployed in here?
Yes. So
Yeah,
the build.
like VM. Yeah.
Or do you pick a VM based upon the RPS in there? Because I'm guessing there's like you want to keep it at a certain CPU level in here, so you wouldn't provision like an A series to go run a couple of billion RPS because first of all, there's no way it could do it. Even if you had a bunch of them, probably it would not work. So did you have something that kind of provides or that handles that piece of it?
Yeah, so in the recipes we have fine-tuned, as you said, based on the CPU utilization. But even in the recipes, if you click, you can change the SKU for the VM. And in the build your own, which Ravi was showing initially, that is a blank sheet, and just put your information.
Okay.
Yeah. Hey, Mark, guys, can you guys hear me? I think I'm feeling some lag.
Your network was had some issues for last past.
Yeah, there was a bit of lag there for about 20 seconds, 30 seconds, but you're
okay.
You're
now I can hear better. Okay, cool. Yeah, so let me hand it over to Naveen. I think he will show something even more exciting.
Okay, Naveen, let's get you up here. Okay, here we go.
Cool. So yeah, so this, what all the Ravi has mentioned, show the framework. What I did before this session, I used it to see how much correct Ravi was saying, and I pushed the envelope all the way to the 1 million.
1 million. So 1 million requests.
Yeah.
Go ahead. 1 million requests per second.
1 million requests per second for read, and then 1 million requests per second per write.
Oh. Right.
So, and I'll walk you through the result. So let me go show how I go into the particular recipe, and we already seen it in this session. So from Cosmos, we will go to the SQL API we are talking about, then read 1 million, and I just clicked on this deploy to Azure. We'll talk about number of the VMs and all the other parameters a little bit, and then go to the result. So here again, like I passed my resource group, storage string, and my credential for the Cosmos. Rest everything was pre-filled for me. This VM size was fine-tuned to have the around 40 to 60% CPU utilization, because that's the industry standard. We picked 15 machines. Each machine we picked around 66,000. If you multiply by 15, it's around 1 million. We set the operation count so that it will run for 1 hour, and everything is like all set. And once I clicked it, I got the result in an hour, and will show you the result. It was done just before this session yesterday. So this is how it looked like. So we have this for all machine. So as I mentioned previously, every machine knows its count. So that's why it is coming up at VM1 all the way to the VM15. So if you see, we have the load phase for all 15 machine, and the CSV file. This CSV file we generate if someone want to create a Power BI report or Excel report. So let me go into one of this just to how it look like. For every 10 seconds, you are having the percentile. So you can create your own graph over the period of time. Now going back, the aggregation. We have this aggregation as well of all these 15 machines. And let's see what it shows. Okay, so it shows that read operation happened. We did approximately 3.6 billion operation. The RPS, the throughput, was little over 1 million. And your P99 was even better than the Ravi you were showing the
Tella.
So 2.4.
The more the better.
Yeah, 2.4, and the average was around 1.3 milliseconds.
Wow.
And we didn't had any failures or any availability issue there during that time, and everything went smooth. Then for the writes again, I will just follow the same routine. Go from Cosmos, select the SQL in the writes, and 1 million writes. To be honest, I was nervous about this guy because this I never heard about 1 million RPS of write. It's not very common scenario. So again, once we click, we'll see some parameter more or less the same as the reads. Resource group, storage account, Cosmos account, and then everything is pre-filled for us. The number of the thread, you will see the number of thread in the writes are a little extra than the reads, and that is the reason, because writes take more time. So we fine-tune the threads accordingly to have the optimal throughput within the CPU cycle of 60 to 40%.
On the writes, do you configure? Do you turn off response on write for the SDK?
So everything is default.
Default.
So
oh, really? So you're actually passing the payload back as well after the write?
Yes.
Oh, okay.
Yes.
Even more impressive.
Yeah. And then the same thing. And let's see the result. So let's go back. This is the read. And the second one I did after the read. And as I mentioned that before we discussed in this meeting, that we can use the VMs. So once my 15 VMs created in the first run read, it took some time, a minute or two, to create 15 VM, and those were the little beefy machines. In the second time, I literally clicked it again, same, and it come in a few seconds, and the workload is started.
So that's great. And I'm guessing for the Cosmos account, it just was an offer replaced on the throughput, basically, right?
Yes, we need to replace the offer.
Yeah.
But it is suggested that if you are doing one recipe to other, try to make a new collection, so to start from the scratch, like not overlap each other. Means until unless you need it, you can still do it. You can still use the same collection, because read load phase start from some different index, and the write start from different index in YCSB. But recommended is to have a clean slate in the Cosmos with a newer throughput, because write needs more throughput. Okay. So here we got the same thing, the load phase, CSV file, log file. And if you see this diagnostic things, in this, if you go, it will talk about the agent, the custom script we were talking about. It will talk about if there is any error, you can even debug by yourself. So now coming back on this, let's see the aggregation of 1 million writes. Let's see.
This will be great.
Okay, so we inserted 3.6 billion records in 1 hour, and throughput was just again above 1 million, and our P99 was 8.4 millisecond.
Wow. How can you, so writes cost more than reads, though.
Yes.
And you've got the same number of operations with roughly the same amount of throughput.
Yeah, so it costs more. That's why we, as you said, we provision the container differently for the reads in comparison to the writes.
Much more higher.
So for the reads, we did as it's mentioned in the documentation. You need to give like the item size was 1 KB, so more or less 1 RU per reads. And the writes you need to give 10 times if you are with indexing. And in this, we have not turned off the indexing. This performance is with the indexing.
It's with indexing. So you have indexing turned on for the writes.
Which is by default. Which is by default. If you go in a Cosmos portal and you turn on something, you turn on, you create a container, your indexing will be by default until unless you will opt out of it.
Got it. So index should cost, or the write should cost you even more, right? Because like an write for a kilobyte is what, like around 7, 8, 9, 10 RU, something like that?
Yeah, so for 1 KB, so this YCSB, they claim that their item is around 1 KB, but with the metadata, it crossed little over 1 KB. So the writes with indexing takes 10 RU, up more or less. And without indexing, it takes like 6 to 7 RUs.
Hey, Mark. So we did provision on the recipe, higher number of RUs for the 1 million write. Is that what you're asking?
Yeah, because when I look at this, you have roughly the same amount of operations, 3.6 billion.
Yeah, but RU is different for the write container.
Like a million RU.
No, it's not million. It's much more than that.
Oh, it is. Oh,
yeah,
okay.
yeah. Go back. Can you go back to the recipe?
Yeah. So let me go back to the link. Give me 1 second.
I think I was looking at that million something and change RU in there.
No. The definition will tell you what account you have to create.
Okay, on the CSV file. So that's where I got confused.
Yeah, I got. So here, let's see the 1 million reads again. And in the documentation, it mentioned how much you need to provision. So for 1 million, you need to provision around 1.2 million RU.
Mm-hmm.
And this 20% extra is just for the skewness in the YCSB, because YCSB is not the load will not go exactly on every physical partition correctly, equally.
Right.
So you need to cover that part as well, so to avoid any throttling. And then for the writes, let's see the documentation.
You have 13 million. Okay.
13 million RU. Again.
Got it. Okay. That makes sense. And you're doing this at provision time. So what is it? I think the heuristic is at 7,000 RU per physical partition at provision time versus, I think it's higher. Or maybe it's closer to 6. I know
six.
Is it 6? Okay. Because I know we create more physical partitions at provision than we do at scale up in there. And that's just primarily just to help, avoid splits early on when you're ingesting data. But that makes sense. Also would be more stable, I guess, as well, because you've got a larger base of physical partitions that you're writing to in there. So, okay. Makes sense. All right. This is, very cool. Everybody should go, everybody, go run this right now. 13 million RU. And I can go and take a vacation with a nice big but you know what, Naveen, your point is right. Like there's not many workloads out there that are needing to do a million writes a second in there. And here you got a workload and you ran this thing for an hour, doing a million writes a second for an hour, which is just an insane amount of requests per second in there. And look at that. That's that P99 of, you're still in SLA. That's just awesome. At 8.4 millisecond in there at P99. And then we're at P50. Your average at 4.5 millisecond. Wow.
Yeah, that shows all the hard work team has been doing from few years. It's just a cumulative work, which we can witness this amazing performance.
Yeah, it's just amazing. Love it. This is great.
Yeah, I think another thing, Naveen, like we always say, it doesn't matter if you're doing 10K or 1K or 1 million, it's still the same click. Nothing special you need to do on the database at all.
Right. And that's the whole point of a scale out database, right? It doesn't matter, frankly, right? The idea is you theoretically have infinite throughput because you just keep adding machines. Everything is shallow in a database like this where you scale out. So it doesn't matter. But this is what's remarkable is, look, hey, your database or your container could be a megabyte in size or it could be a petabyte in size. Your performance is going to be the same no matter what, all up and down there. And what you're showing is exactly that in action by virtue of this benchmark and the results that you got out of it. So this is awesome. I mean, see, this is why I'm excited all the time.
Thank you. Thanks for the kind words.
First time ever on this show that I've had someone show me 1 million writes a second or a million reads a second going in and out of Cosmos. So that's why that's why I had to have you guys on. This is just
in fact, when it was done for the first time, I think I'm 100% sure Naveen did it like a few months ago. I think he's probably the first person within Microsoft who has ever done this. Maybe
you might be I don't know, first person ever. I don't know. I know we have some customers that.
Yeah, it is in Microsoft, maybe.
That push the boundaries on scale. But this is awesome. This is awesome, and to see it right there. So, a couple of links I want to put up there. You guys have a new article up on our docs, so this is a good place to get started as well, right? Up on our docs here. So, if they just want a kind of a quick intro on how to start, they can go to your page on the docs page, the Cosmos-benchmark-docs. Is that right? And then also I wanted to put back up, because they can get to it from there as well, is also the link to your GitHub repo that you're showing here. Well, not this one particular, Ravi. This is your fork of this in there, right? Oh, that's not the repo. That's your actual benchmark.
Framework.
Got it. Yeah, that's Portal. So there you go. Yeah.
Yeah.
So is the 1 million in there? Is that a fork of your local fork of that repo?
No. This is it. Everything is here.
Everything is.
So you got the million RPS test is in there. Okay. Yeah.
Yeah, 1 million here. It's in a main branch.
Yeah. Awesome. Okay.
And one thing, as this is the project we started with a vision of making it easy for everyone, including us, for our side. So we will really appreciate if someone want to contribute in this repository and bring more ideas and more areas to expand.
Okay. Well, I'll put that link back up. So aka ms/cosmos-benchmark. And if people want to go and fork this, and then if people want to contribute in, they can just submit a pull request for you guys, right?
Yeah. Okay. And I think we are going to like Mongo API is now available, and we have some other partner team who are wanting to add Cassandra API. Another thing me and Naveen are also looking into it is so right now everything runs on the VMs, right? But a lot of our big customers, they use AKS, Kubernetes containers. So instead of using just VMs as an option for the clients, why not run these workloads from a Kubernetes cluster, right? To make it more close to what most customers would use. And of course, the .NET client as well.
Yeah. Okay. Any ETA on when you'll have the .NET recipes out there?
I think later in the Gallium.
Okay, maybe. So end of summer, early fall.
Yeah.
Yeah, around that time, like the last quarter of this year.
Last quarter of 2023.
Yeah.
Okay.
Just because I think the other items are of a little bit higher priority, but you never know if we are working with other teams as well.
That .NET thing is we have to see which tool is globally accepted by the non-relational database users. So again, we are happy if someone want to put some detail, they can create an issue, suggest us what they want us to use. So we are open on that part as well.
Okay. Yeah. Yeah, very cool. Well, this is great. Gentlemen, thank you very much for coming on and just blowing us all away with the performance and the work here in these benchmarks. I just want to let everyone know, hey, folks, we've got a user group monthly happening every month here, aka ms/Cosmos DB user group. Come and check us out. I think this is episode 76. I think. Come check out all the other previous episodes we've got. You can check those out at aka ms/Cosmos DB live TV. And that's it for us this week here. Ravi and Naveen, really, thank you so much. This was really quite a remarkable show.
Thank you.
Thanks a lot.
Okay. All right. Thank you.
Bye.
Thank you, everyone. We'll see you next time.